Welcome to Game Developer Unity. Are you ready to take your first steps into the world of game development? Video games are one of the most complex art forms to date, and mastering the fundamentals of game development requires a lot of practice and patience. That's why many professional game developers recommend starting small, creating multiple smaller projects before diving into your dream game. This challenge is my attempt to simplify the learning process for anyone who dreams of making their own video games. Today, we're building a classic game, Tic Tac Toe, in Unity. This project is simple yet powerful, teaching us key mechanics like turn-based gameplay, grid systems, win detection, game loops, and grid-based movement. By the end of this challenge, you'll not only have a functional game but also a strong foundation to tackle more advanced projects. Let's dive in. First, let's set up the project. Open Unity and create a new 2D project. Name it Tic Tac Toe. Once the project loads, clean up the scene if needed and add a UI canvas. You can add UI canvas by right-clicking in hierarchy, choose UI and canvas. By this you can create a canvas for our game. You can also see that the event system is also added when you create a canvas. If it's not added, then an event system using right-click UI and choose event system. In Canvas, change UI scale mode to scale with screen size. In Unity, the Canvas scaler component's UI scale mode controls how the UI scales with the screen resolution. It has three options: constant physical size, constant pixel size, scale with screen size. Scale with screen size scales the UI to match the screen resolution. You can specify a reference resolution, and the UI will scale up or down to match. Now, we'll design the game board. Start by creating an empty game object under the canvas object and name it Game Board. Add a grid layout group component to it from the inspector. This component helps us create a neat grid layout for our cells. Next, customize the cell size to 100 by 100 and add some spacing between the cells. For this tutorial, let's use 5 by 5. Then, resize the game board to fit nicely within the canvas. Once that's done, we'll add a button to represent a cell. Right-click on Game Board, go to UI, and add a button. Rename it to cell_0 feet. Remove the text inside the button to keep things clean. Duplicate this button 8 more times to complete the grid. Rename each button sequentially, cell_1, cell_2, and so on. Naming like this will help you when really wanted to find bug in complex projects. Now, our game board is ready for action. I have downloaded two sprites for X and O that we are going to set when respective users click on these buttons. For a good visual of our game, we are going to get our background. Right-click on hierarchy, click on UI and create the image and name it background. Click here on the rect transform with the Alt key on the keyboard, choose stretch. You will end up getting like this. Now set the background color you want. I am going to get black color for this. I also wanted something to let the player notify whose turn it for that. We do two things here. First, we add on text that will let player know whose turn, and the second thing we are going to do it add some sprite here that will change according to players. First, let add text. Right click on hierarchy, then UI and select text mesh pro. This will add one text component under your canvas. Let's name it text_notification text. Set the position where you like to show the text. Let add two images quickly and set them as you wanted to show and named it X design element and O design element. With the game board set up, let's move on to the exciting part, game logic. Start by creating a new script called Game Manager. This script will handle player turns, check for winning conditions, and reset the game when needed. First, let's create an empty game object and name it Game Manager, and drag the Game Manager script into this object. Let's open the script. I have already set up this Game Manager. Let's understand what the script does. Here we have created an array name buttons that will hold all the buttons and assign them in the inspector. Here we will have a string variable name current player that will indicate which player has turn. Next also we have a text mesh pro variable named text_notification text. This text will be used to notify the player whose turn it is and name of the winner. We have downloaded two sprites for X and O. For that we have declared two sprite as public variable X letter and O letter. These are in the white color, so from the script we are going to set the color of the players. That's why we have declared two public variables color of player X and color of player O. Here we have declare X design element and O design element variable that we are used for player's turn. The most important function here is the make move function. The make move function is the core of the gameplay, handling what happens when a player clicks a cell. First, it checks if the clicked button's text is empty, ensuring players can only make moves in unoccupied cells. Next, it assigns the current player's symbol, X, or O, to the cell. If it's player X's turn, the button displays the X sprite and applies a specific color to distinguish player X. Similarly, for player O, it updates the button with the O sprite and its respective color. After updating the visuals, the function checks for a win condition by calling checkWin. If a player has won, it displays the winner's name in the notification text, logs the win to the console, and resets the board for the next game. Finally, instead of directly switching turns inline, it calls the change player turn function, keeping the code clean and modular. This ensures that the game flows seamlessly, alternating between players after every valid move. With the make move function, the game not only handles gameplay logic but also delivers a polished visual experience for both players. Here make move function called checkWin function. The checkWin function is the heart of our Tic Tac Toe game, determining if a player has won after their move. It starts by defining all possible winning conditions in a 2D array. These include the rows, columns, and diagonals of our 3x3 grid. Each set of 3 numbers represents the indices of the buttons that form a potential winning line. This part of the code defines all the possible winning conditions in a 2D array named win conditions. The array contains 8 sets of 3 integers each. Each set represents a group of button indices that form a possible winning line, either a row, column, or diagonal. For example, 0, 1, 2 represents the first row, where buttons at indices 0, 1, and 2 need to be the same to declare a win. 3, 4, 5 represents the second row, with buttons at indices 3, 4, and 5. 0, 3, 6 covers the first column, involving buttons at indices 0, 3, and 6. 2, 4, 6 covers the diagonal from top right to bottom left. This structure ensures that every possible combination of 3 cells is evaluated to determine a win. By checking these conditions during gameplay, the game can accurately recognize when a player achieves victory. Next, the function loops through each condition in the array. For every condition, it checks whether the text in the 3 corresponding buttons matches the current player. If all 3 buttons have the same symbol, either X or O, it means the current player has won, and the function immediately returns true. If no winning combination is found after checking all conditions, the function returns false, allowing the game to continue. This logic ensures that the game evaluates every possible way to win and accurately detects when a player achieves victory, making it a key component of our game's functionality. Next, the make move function called change player turn. This function, change player turn, is responsible for switching the active player after every move. Here's how it works. It checks the value of current player. If the current player is X, it switches to O. Otherwise, it sets the player back to X. This simple if-else logic ensures that turns alternate seamlessly between the two players throughout the game. By keeping the turn switching logic in its own function, our code stays clean and easy to maintain. It also allows us to reuse this logic whenever needed, making the game flow smooth and intuitive. Change player turn function called another method named set player turn design element that sets the text to notify whose player's turn it is. Also, we have set the condition as per player's turn. We have set the design element active and deactivated and set the colors. We add a reset function to clear the board and restart the game, and it will load the scene again. This ensures the game loop is smooth and reusable. At last, in the start function, we are going to assign the make move function to all the buttons by using this lines button.oneclick.add listener make move function. In the Unity editor, don't forget to assign all the things we have declared. Assign all the buttons, then notification text. Assign the sprite and assign the game object here in X design element and O design element. Set the color as you like for two players. Now it's time to playtest. Hit play and check if everything works as expected. Make sure turns alternate correctly. Test the win conditions for rows, columns, and diagonals. Ensure the reset functionality clears the board and starts a new match. Congratulations! You now have a fully functional Tic Tac Toe game built in Unity. And there you have it, your very own Tic Tac Toe game. In this tutorial, you've learned how to implement key concepts like grid systems, turn-based mechanics, win detection, and game loops. These skills will be invaluable as you tackle bigger game dev challenges. Let me know in the comments how your Tic Tac Toe game turned out, and feel free to share any cool features you added. If you enjoyed this video, don't forget to like and subscribe to Game Developer Unity for more tutorials like this one. Until next time, happy coding!